Let's look at surds. Surds are numbers that are left in root form when we cannot simplify the number to remove the root. Examples of surds are square root of 2, square root of 3, cube root of 7, etc. Examples that are not surds are the root of 4, the root of 9, the cube root of 8, etc. Now these are not surds because they can be simplified as follows. The square root of 4 is actually the root of 2 times 2, which is 2. The square root of 9 similarly is 3, and the cube root of 8 is the cube root of 2 times 2 times 2, which is 2. So let's identify whether the following is a surd or if it's not a surd. So the square root of 5, is this a surd or is this not a surd? The square root of 5 is a surd because we cannot simplify it any further. Identifying between which two integers a surd lies. So let's look at the square root of 5. The root of 5 lies between the root of 4 and the root of 9 in the table that's given in the book there. Therefore, the root of 5 lies between the integers 2 and 3. Another example here, the cube root of 100, that is between the cube root of 64 and the cube root of 125. Therefore, the cube root of 100 lies between the integers of 4 and 5. Let's look at what we are given here. The square root of 7. The square root of 7 lies between the square root of 4 and the square root of 9. So the integers that the square root of 7 would lie between would be 2 and 3. The cube root of 50 now. The cube root of 50 would lie between the cube root of 27 and the cube root of 64 in the table in the book there. Therefore, the cube root of 50 would lie between the integers of 3 and 4.